Okay, my students, now we are in the last section of October 2023, Unit 5, Chemistry. That's me, Bishr Samhan, on our platform, MetaStars. In this question, it's a context studying question. It's an article question. They ask you about the salicylic acid. The salicin was extracted from the bark of willow trees in the first half of the 19th century. About 30 years later, scientists showed that salicin was converted into salicylic acid and in the body, and this is the structure of the salicylic acid. The salicylic acid was given to the patients with fevers and their symptoms were reduced. However, it caused severe irritation to the lining of the mouth and esophagus and the stomach. In the 1890s, Hoffman's converted the salicylic acid into acetyl salicylic acid, which is commonly known as aspirin. So it's a history about the aspirin discovery and how it is manufactured and is still used to treat fevers and as a pain killer. That's the structure of the acetyl salicylic acid. The salicylic acid may also be converted into methyl salicylate, and this is the active ingredient in the oil of wintergreen, which is applied extremely to treat joints and muscle pain. So all these structures are for painkiller and fever symptoms. Okay. What is needed? Give the APAC name for the salicylic acid. Let us return back to the salicylic acid formula or structure. What is the name of this structure? You can see that. We can start numbering from this. So you will see it is benzoic acid and it's on. That's the benzoic acid, and that's number 2. So in 2 we have hydroxy group. So its name is 2-hydroxy benzoic acid. That's the name of the structure. So the name is 2-hydroxy benzoic acid. Okay. Acetyl salicylic acid is formed when the salicylic acid reacts with ethanoic anhydride, and he gave you name the 3 functional groups in the acetyl salicylic acid. Let us return to the structure and name the functional groups. So you will find where is it? That's the acetyl. You have carboxyl group, you have ester group, and the benzene ring. So the structure includes these. This is the carboxyl group, and this is the ester group, and this is the the aryl or the benzene ring groups. Those are the 3 functional groups. So the 3 functional groups of this are the following. You have ester group. Okay, you have ester group carboxylic acid and aromatic or benzene ring. Okay. The next one is write an equation for the reaction of salicylic acid. I can take the structure, okay, from the paper itself. Okay, so it is like that, this salicylic acid with an ethanoic anhydride. So we'll draw the structure like that. It is, okay, this is the structure of from the question. That's the structure of the salicylic acid, which is COO, and we have OH group. This is plus the CH3, so it will be CH2 CO by 2. So this is plus CH2 CO by 2O, since this is CH3, sorry, CH3 by 2 CO2, because it's a structure like that. You will see CH3, C double bond O, C double bond O, CH3. That's the structure. So you will write the structure like that, and in the middle you have ethanoate, ethanoic acid anhydride. Okay. This will give us what? This will give us this structure. The first one is here. We will do the carboxyl group, or the carboxylic acid as it is. And here this will react with OCOCH3, and the second part, it will be the carboxyl plus CH3 COOH, which is given from the alcoholic part. Okay, now the next part, 2 grams of salicylic acid produced 74% of acetyl salicylic acid. Calculate the mass of the acetyl salicylic acid formed. The ratio is 1:1, and he gave you the molar ratio of salicylic acid and acetyl salicylic acid, 180. The first step, you can start by finding the number of moles of the salicylic acid. So the number of moles first, moles of salicylic acid, okay, equals the mass over the molar mass, which is 138. It is like that, 2 over 138 equals how much? It is 0.0149 or 493 moles. And then you can find the theoretical mass of the salicylic acid. or acetyl salicylic acid, because the molar ratio is 1:1, so the mass theoretical yield equals the number of moles times 180, and this will give us 2.70, or sorry, it's 2, it will be 2.6087 grams. And then after that, the actual mass of acetyl salicylic acid by using the percentage, it will be the mass of the acetyl, the actual mass by using the theoretical, and the actual, it's 2.6087 grams times the percentage yield, which is 74.8 over 100. That equals 1.9513 grams. And you will see it is in grams. You can round the number to be 195 grams, like that. Keep your answer, keep your calculations for the last step, then do the rounding. Okay? Don't do the rounding from the beginning. Now here give you the acetyl salicylic acid is only slightly soluble in water, and it has Ka value of 2.8 times 10 to the power -4 mole cubic decimeter. Complete the equation to show the dissociation of acetyl salicylic acid. This will give you the dissociation, and you can see that the acidic hydrogen is this one. So the dissociation of this is only, you have one mark for doing this, so it's COO negative, and here it's OCOCH3. It's kept the same, and this is plus hydrogen. And state symbols are not required, or you can write them since it is AQ. Okay? Now, the next part of this section, the dissociation of acetyl salicylic acid is different in the acidic conditions found in the stomach compared with the slightly alkaline conditions in the small intestine. Explain this difference in dissociation. Okay. You will see that the stomach, the stomach solution is highly acidic, or because it is stronger acid, it will be decomposed more. So what we can write about that, it will dissociate less in the acidic solution or more in the alkaline solution, because the addition of hydrogen ion in the acid will shift the equilibrium to the last part, and the OH hydroxide ion in the alkali reacts with the hydrogen ion, shift the equilibrium. Okay. So the answer will include these things. So the acetyl salicylic acid, let's return back, to the question. The acetyl salicylic acid, wait, here, the acetyl salicylic acid, weak to dissociate slightly compared to the other acid, and adding OH or alkaline will shifts the equilibrium to the left. And this makes the more concentration of acid in the left side. Okay. Now, for next part, identify by name the formula reagent needed to convert the salicylic acid into methyl salicylate. You can select what the acetyl, you can write methanol because acetyl salicylic acid. It is to methyl salicylate, you can select methanol because it's a kind of esterification here by the name or the formula, or you can write methanol. This is according to your experience in the reaction mechanism and in the names of the reagents which they react with each other. Now the high resolution proton NMR spectra of acetyl salicylic acid and the methyl salicylate both contains 4 peaks from protons on the benzene ring and 2 other peaks from the OH and CH3 protons in the side chain. Complete the table to give the chemical shift range that you would expect for each type of proton in the side chain of the molecule. Okay, if you return back, he's asking about the chemical shifts of each OH in each part, and if you return back to the data booklet, you will find these values only. So here we are, he's asking you about this one, and he's asking you about this one, and this one, and this one, because they are, this is for the ester one, this is for the anhydride one, and this is for carboxyl one, and this is for alcohol one. Now the chemical shifts are from left to right as the following. They are like that. So you can write the chemical shifts range. It's from 10 to 12. And here it's from 1.6 to 2.8. And for OH group in methyl salicylic acid, it's a 3.8 to 7.6. Or you can write a value between these two ranges, 2.8 to 4.3. I got the values from the data booklet. So you can write the values between these ranges. Okay. Or you can write the range. Now, acetyl salicylic acid in aspirin tablets is hydrolyzed by excess sodium hydroxide. Okay. And the unreacted sodium hydroxide may be titrated with a standard solution of hydrochloric acid to determine the percentage of acetyl salicylic acid in the table. Aspirin tablets can be analyzed using the outline procedure. First, he added 25 of cubic centimeter of 1 molar sodium hydroxide to know the mass of the powdered aspirin tablet. Okay, it will react. And you can see it's 2-to-1 molar ratio. Heat the mixture for 10 minutes to hydrolyze the aspirin. Cool down the mixture, make the solution up to 250 volumetry flask. And here he used the analytical way method, the volumetric flask. So this is the standard solution. And pipette 25 of the hydrolyzed solution into the conic flask of titration, and 0.1 hydrochloric acid using phenolphthalein indicator its normal titration. Repeat the titration until the concordance values are obtained. The result is mass of aspirin is Ba and or is 0.76 grams and mean titer 16.95. That's after different trials. The table shows the percentage by mass of acetyl salicylic acid in 4 brands of aspirin tablet. Then the question is, determine which brand of aspirin tablet was analyzed. You must show your working. Okay. It's clear that it's normal titration procedure. It's an acid-base titration, but we have 6 marks, so 6 steps. Okay. First of all, you can start from the titrant, which is used, and the titrant has which is NaOH. Now, we can start from the moles of AOH, of sodium hydroxide, moles of NaOH. That equals the volume, 25 over 1,000, times its concentration, which is 1, and this equals the 2.5 times 10 to the power negative 2 moles. Then you will find the moles of HCl, which is in our sample, in the sample which is taken from the standard solution. So this equals the 16.95, or from the question, over 1,000 times 0.1, its concentration. So this will give you 1.695 moles. Then the moles of NaOH remaining in a 25 equals how much? It's the moles of NaOH remaining in a 25 equals, it's times, this is times 10 to the power negative 3. And the moles of remained NaOH after titration, it is 1.695 times 10 to the power negative 3 moles, because it's back titration way. And then in moles remains in, this is in a 25 cubic centimeter. Now multiply this by 10 to get remained in 250. This equals 1.695 times 10 to the power negative 2 moles. It's a way, it's again, it's a back titration question. Then the moles of NaOH, which is needed, it is now the moles of HCl, which is reacted with salicylic acetyl salicylic acid, equals 0.025, that's used in the beginning, minus the answer, which is 1.695 times 10 to the power negative 2 equals how much? It is 8 point, how much? It's 8.05 times 10 to the power negative 3 moles. Now the moles of, this is for NaOH, that's reacted with the acetyl salicylic acid. Now the moles of acetyl salicylic acid, okay, salicylic acid, good, equals salicylic acid equals 0.00805 over 2. That's equals a half, and this equals 0.04025 moles. Then what is left is to find its mass. Okay, so the mass of the acetyl salicylic acid, the mass of acetyl salicylic acid equals what? The moles, which is 0.04025 times 180. This will give us a mass of 0.7245 grams, and the percentage equals is 0.7245 times 100 over the actual one, which is 0.76. That's equals 95.325%. Okay, so my students, that's everything about the paper October 2023. Try to solve it again and compare your solving with what we did in our videos. That's me, Bishr Samhan, your chemistry teacher on MetaStars platform. It's your way for a star. Bye-bye.